So in this next video, we're going to talk about chain of thought and OpenAI's new O1 model.
TSMC executives calling Sam Altman a podcast bro was definitely not on my 2024 bingo card. Okay, that's not the right news I was going to talk about. Sam Altman has restructured OpenAI from a non-profit to a for-profit, with them just raised the largest VC round in history at 6.6 billion, valued at 157 billion. Wait, that's also the wrong news. Let me see. Sam Altman now remains the last out of the big four because of culture clash. Oh wait, that's still the wrong news. OpenAI has released a new model series called O1, codenamed Strawberry, which made a staggering leap of progress. Oh yes, that's the right one that I wanted to talk about. And these few news I just mentioned all happened after O1 released. Hopefully O1 is not in the back of your head already, because this model series is an interesting one. The major selling point of O1 is that it natively incorporates chain of thought, where the chatbot pretty much talks to itself first for anywhere from 5 to 60 seconds, then tells you the final answer it arrives at. This is the concept of test time compute and has now been introduced to the masses, where allowing the model to yap for a little bit before giving you an answer has proven to be highly effective in improving performance. It's so effective that the reasoning capabilities of AI took an insane leap on the benchmarks, and you know, it's gonna be spicy when OpenAI doesn't allow you to see their chain of thought process under the hood. But the irony of that is, since generating tokens is their service and they don't want to show their chain of thought tokens for moting purposes, as a result, we are basically paying for tokens that we can't see. Well, for the web version, at least you get to see a summary of the chain of thought, but when you use the API, you actually don't see anything. But a performance increase is a performance increase. So instead of getting wildly inaccurate answers in a split second for GPT-4o, O1 model will perform a 360 no-scope high-rise crane shot into a Ronda Zook on top of a helicopter J-hook landing, just to tell you that the word raspberry has 19 R's, while it actually has 21 R's. And we might just point to the chain of thought and say that it hallucinated one fewer R in this step and that step, which led to that mistake, along with the fact that it miscounted in every single step. However, out of all the extreme questions AI models can now solve, why are people still so hung up with AI recognizing 3 R's in the word strawberry anyways? Well, let me get psychological a bit, and that might have to do with the distrust we have in AI. Ultra-crepidarianism is a word that describes the act of giving opinions on matters outside the scope of one's knowledge. And in this paper, larger and more instructable language models become less reliable. They empirically found that newer and better models are less likely to avoid answering when they are unsure, and instead love giving confidently incorrect answers, including errors on difficult questions that even human reviewers frequently miss. The AI's tendency towards ultra-crepidarianism might make users trust the AI doing tasks they don't fully understand at first, but would usually lead to an immense disappointment for the users somewhere down the line. So if we see AI fail at doing tasks which are easy for us to do, then there is no way we will fully trust it to solve things that are way over our head. So other than testing to see if an AI has overcome its limitation on tokenization, the Strawberry test may have also been a psychological test that we have set for ourselves unknowingly. On the other hand, interestingly, older models that weren't scaled.
So the two things we've got so far are chain of thought, then there's test time compute, then there's the efficiency gains of test time compute, which we'll add here. Mainly across mathematical benchmarks, more reasoning-based tasked.
Up would be less likely to start spouting BS. So how did we end up with AI trying to gaslight us back after all this time? Another paper called Language Models Learn to Mislead Humans via RLHF gave us some pretty interesting insights about it. In their study, they found that RLHF, which is a method that turns knowledgeable AI models into interactive chatbots, improves the model's ability to persuade users, but gets worse at replying correct information. On top of that, RLHF also makes the model harder to evaluate rate, resulting in a significant increase in the false positives rate for human reviewers compared to the baseline. So as the RLHF techniques improve over time, the better they get at misleading humans. And the thing is, no one is going to trust an elevator that failed once, so this is one of the main reasons why AI won't be a part of the critical infrastructure, and even if an AI is involved, humans will still be the ones overseeing them. So it is not too late to get into critical infrastructure while making the most of AI, which is also a perfect opportunity for me to introduce NVIDIA's certification programs that they want me to share with you all. Given the pace at which AI technology is evolving, training humans has become a strategic priority. Other than making sure we don't get smooth talk by RLHF into giving over the critical infrastructure, staying ahead of the AI progress with the latest tools and skills is also important too. With this training and certification from NVIDIA, you will learn from industry experts on how to build and run next-gen applications such as generative AI, accelerated computing, and 3D simulation. This includes role-based courses, hands-on labs, and customized learning paths to ensure the training provides tangible results for you. With certifications ranging from infrastructure, operations, infinite band, to even multimodal in LLM's Gen AI, you can become an NVIDIA certified associate or professional, which will also set yourself and your team apart in the industry. Moreover, they also offer 2 additional learning resources. The first one is called Generative AI Learning Path, where you can learn how to build and deploy Gen AI powered solutions, which helps you master generative AI. This program covers the fundamentals and the applications specific to production courses, with 2 separate learning paths, one for developers and another for administrators. The second one is called the AI Learning Essentials, which is designed to equip students in their early careers with the knowledge and skills needed to thrive in the dynamic and collaborative environment AI has created. It has free self-paced courses on OpenUSD, RAG, Jetson Nano, and even an introduction to CUDA. So go check them out using the link down in the description. And for all self-paced courses, certificates, and instructor-led workshops, you can use the code ByCloud for 10% off. And thank you NVIDIA for sponsoring this video. Anyways, OpenAI's O1, codenamed Strawberry, might be referring to the chain of thought process as the strawberry on top of the cake, where the cake is an already capable pre-trained model.
So the idea that there's improvements in the model is fine. There's actually not much content there. The key limitation is whether it's just knowledge processing or acquisition. So we can add that. But if all it does is just use the information that LLMs already know, that information is all human knowledge on the internet, so that's still pretty strong.
With this Strawberry technique significantly improving in areas like math and reasoning, it's also interesting to see that other areas such as English language or literature have shown barely any improvement. This is also the first time I see some insanely disproportional capability increase for a new AI model. Like if you train a model on codes, all capabilities still generally increase, but here with O1, they fine-tuned it with chain of thought and its English capabilities barely budged, even though the model improved in the logical reasoning aspect. Does that imply literature doesn't require any thinking? While we may not fully understand why chain of thought can specifically improve LLM's reasoning and math capabilities, especially with OpenAI flexing on the side without helping, there is still a lot of related research out there that might give us a bit more insights. Like in this new research paper where they conducted a meta-analysis over all the current existing papers about chain of thought, it proved, yet again, that chain of thought is primarily beneficial for tasks involving math or logic. And for other types of tasks, there isn't a significant difference when using chain of thought. In the last video about prompt engineering, I mentioned a possibility where LLMs just need more tokens to be conditioned on in order to generate more accurately. But later in the video, I then discussed some research that disagreed with this idea. The main disagreement is that chain of thought might just be a facade, as the model may just simply need more time to process before generating. Chain of thought appears to work merely because it happens to be easily interpretable by us. And this other research supports this disagreement too, where they found out that filler tokens do help the model to improve performance, and that is because the extra hidden computation during the inference process created by the filler tokens help to increase the performance. But the real juice has to come with this very new paper called Chain of Thought Reasoning without prompting. So a lot of research focuses on specific prompting techniques such as few shot or zero shot chain of thought prompting, but that is like scratching the surface of the model. This paper discovered that there are already good reasoning processes within a model, it's just that how we implement implemented the method to generate tokens ends up ignoring it. So to give you a more basic rundown, when an AI model is selecting the next word token to predict, it generates a list of probabilities for every possible word that could come next. Most decoding methods use greedy decoding, where we just pick the words with the highest probability and let the model generate based on that. However, when the AI is at the start of a sentence, let's say to answer a question, there is not really a correct way to generate the first word. So even if you pick the word with the highest probability to start a sentence, it may not result in the best outcome the model can generate. So instead, we would have the AI choose the top 5 tokens to start off and observe which one provides a better answer, and usually the models tend to display a higher confidence in decoding the final answer when something like a chain of thought reasoning path is presented. This then brings us to the idea of test time compute, the latest buzzword in town. OpenAI has been promoting this idea as the next big scalable frontier of AI models, which will revolutionize the field even further. Yeah, we'll get back to that. But yes, test time compute includes much more than zero-shot chain of thought, and the chain of thought you guys all know and laugh about is actually the worst type of test time compute method you can use your compute on. Test time compute goes way beyond it. It includes methods like reward modeling, self-verification, search methods, best of unsampling, star algorithm, verifier, Monte Carlo tree search, and many other techniques.
Yeah, so rather than just chain of thought, you've got a few different test time compute methods. Have I got any other ones listed?
That actually make sense. So if you look past chain of thought, they are not all just pointlessly generating more text tokens when you ask it a question. And of course, finding a compute optimal strategy for scaling test time compute is extremely important, and probably what OpenAI is researching on. But we'll never share! They gotta fucking change their company structure! My ass will change their name too, Jesus Christ! So it is pretty much proven at this point that with additional computation at test time, an LLM should be able to do a lot better in logical reasoning tasks. But keep in mind that this extra compute is only able to draw out the existing knowledge as opposed to obtaining new knowledge. As for the next closest thing we have in order to learn more about test time compute on a large scale, this paper released by Google DeepMind called Scaling LLM Test Time Compute Optimally Can Be More Effective Than Scaling Model Parameters answered a lot of our questions. The key question of their paper is, if we match the compute costs between two approaches, a small model with extra inference compute versus a large model with a standard inference compute, which one is going to be more compute efficient? In their experiment where the compute is matched, they discovered that for easier questions, using additional test time compute on a smaller model can outperform a model that is 14 times its size that is using a standard amount of inference compute, making the smaller model with test time compute more efficient in this case. But for more difficult questions, having a larger model that spends its compute on pre-training becomes more advantageous, like.
So that's pretty interesting, the Google paper. We can just save that note.
By a lot. Using test time compute has diminishing returns on these questions, and spending the compute on pre-training data is just more effective. And this conclusion does also support the idea of how test time compute is destroying existing knowledge.
Okay, so this is getting way too congested, so let's cluster them into chain of thought, scaling, hypotheses, test time compute, method, paths, future, progress.
Out and refining it as opposed to gaining new knowledge that pre-training provides. On top of that, this result was drawn from not just one, but two different test time compute methods which produce similar results despite handling them in completely different ways. The first type of test time compute is called search against verifiers, which is basically post-generation filtering. So you basically have the model generate multiple answers at once and utilize a reward model to pick the best answer. How the model generates multiple answers can vary from best of n samples to Monte Carlo tree search, but at the end of the day,
So future progress, decoupling of scales, that's pretty interesting. Clustering is pretty good. Test time compute beyond pre-training. This part of the video. Test time compute methods, so these are more I think these are just more methods, so worth including.
The method just needs to let the model provide a range of samples for the reward model to pick a final answer from. The second type of test time compute is called modifying proposal distribution. This type of method is mostly reinforcement learning inspired techniques where the model refines its own output step by step, like STAR, aka self-taught reasoner, or reinforcement self-training. So instead of selecting the best response after generating many options, the model refines its own output step by step using additional computation to correct or improve upon previous outputs. Kind of like patiently choosing which token to generate next using all the available information while backtracking if the answer is bad, instead of generating a path algorithmically hoping to get the best answer out of all the guesses it took. Additionally, there are a few general rule of thumb for test time compute disregarding their type. Things like too much checking will backfire, overthinking will backfire, reward model too strict or intervene too much will backfire. So basically LLM getting backseated too much will backfire on its performance. So what do we learn? There are two main types of test time compute, and OpenAI probably used the first type as people speculated they used some search methods for their chain of thought. Another takeaway is that test time compute is only good when the proportion of compute spent on inference tokens is much less than the pre-training tokens. So the proportion of compute used in inference should never surpass its pre-training compute, as the scaling law proposed by DeepMind suggests that doing so would lead to diminishing.
Okay, so that's interesting. Here's the Google paper. Inference compute shouldn't exceed pre-training compute
returns. More specifically, in some easy question settings, it is more effective to pre-train smaller models with less compute than apply test time compute to improve models' outputs. But for answering hard questions, there are little to no benefit from scaling test time compute, and it is more effective to increase the capabilities of a model by applying additional pre-training compute. This tells us that scaling test time compute is not one-to-one interchangeable with scaling pre-training, which is definitely the opposite of what OpenAI is trying to make out of, because in their latest O1 blog, OpenAI just threw this graph up and wants everyone to believe them that this new scalable aspect is really that powerful and scalable from their experiment. Like, look at how they're trying to make the dots into an exponential. Well, at least now you have a more fair and balanced perspective on the future of test time compute. While it still provides a new way for companies to enhance a model's performance, I still doubt this will be a big paradigm shift, with large-scale experiments from DeepMind.
Yeah, that Google paper is actually really interesting because it suggests that there's a limitation to test time compute that I didn't think about.
Showing that test time compute scaling is not always as good as pre-training, it does feel a bit limited and only like a strawberry on top of something great. Maybe test time compute might make code generation more reliable due to its reasoning capabilities, but so far, not many results are backing that up. So the real question now is, with OpenAI officially acknowledging Claude 3.5 Sonnet as the best available model, how did Anthropic manage to create a model that is so good at coding? Anyways, after I read about test time compute, my thoughts now point to the idea that smaller models are really underexplored, and there are still quite a lot of space for compute optimal LLMs to develop. Or maybe LLM is just constrained in the text-based modality, with vision language model being the next big thing. So yeah, that's it for this video.